Good evening, brothers and sisters. It is 9:20 p.m. Central Standard Time here in the United States on February the 6th, 2022. Hope our Creator is keeping you well and safe wherever you are in the world. And we are looking at an update according to Enlil, our Sumerian Anunnaki god. And we are seeing that flare from this morning, or that C flare with the decent coronal mass ejection, that is directly coming at us. As I was saying this morning, it definitely looked like it, and it would appear that the data has caught up, and it is correct. It looks like it's going to hit us on the 10th, between the 10th and the 11th. And from the colors of it, it looks like we're going to be getting between 30 and 40 centimeters cubed on this. So yeah, buckle up. Let's go take a look at Euphoria on European Space Agency and see what they have to say. And they are definitely behind, because they're showing the eruption from the 30th that had already arrived and left, and it's showing us here, which was on the 3rd, and today is the 6th, so we were back here. It has not been brought up to date yet. Well, one of the things I did notice, now that we're over here at Space Weather Prediction Center, looking over here at LASCO C2 and LASCO C3, is that LASCO C2 has got some data missing from 848 to 1436. That's 6 hours, ladies and gentlemen. And as you can see, as we jump forward, we can see this looks like a coronal mass ejection right here out the bottom end. But as we continue to play, it looks like we can start to see the little wave right here coming off of the top. We'll have to go take a peek at seeds and see if we can see it there too. So that's LASCO C2. Now in LASCO C3, oh, look at that. Yeah, it's 4.5. That's 5 hours of missing data. Yeah. Oh, 6 hours actually. 6.5 hours. Yeehaw, right? I think, if my math is right. I don't know. I'm kind of tired. But, yeah, we can see the coronal mass ejection coming off the bottom, and well, it doesn't quite reach the top yet. But there's some activity going on out there. Whoa, man, that is a big, ugly jump, isn't it? Huh. All right, let's go check out SDO and see this this nice little pop. But before we do that, we're going to jump over here to seeds, and we are going to take a look at our ink filter, reversing filter. It's just black and white instead of the red. So let's take a look at that coronal mass ejection. Oop, it is going the wrong way. Oh, dang it. There we go. Hit start. And let's see here. There's one off the right side. Off the bottom. Oh yeah, look at that. That is a halo CME. So that is directly coming at Earth. We're definitely going to be taking that one right on the chin. Yippee-ki-yay. Buckle up for that one. Now we're going to jump over here looking at SDO. That's Solar Dynamic Observatory. We're going to look at 304 angstroms of light. And this is going to allow us to see the plasma as it comes off. Now this is on the 5th. We're going to have to wait for it to catch up to the 6th, but this will kind of give us a good idea of what's been going on the last couple of days. Of course, we've seen our eclipsing mothership blocking the satellite for like 9 days in a row now. You see all this plasma coming off. All over here just dancing around like crazy. But the area in question is right here. Now we'll see some come off here, and then this gives a nice little whirl. Watch this. Whoosh. That is a nice display of plasma that is coming our direction. So, yeah, we'll see how dense it is. If it even looks like it's still spewing out a little bit there. Do you guys see that? Well, alrighty then. Coming at us live from the sun. Let's come on down here to this guy here. We're going to come down and look at it in green, which is 94 angstroms of light. And we're going to see it again right here. We're going to see it come off of this section right here. And it was a long duration event. See, boom. Ooh, yeah, that was the nice C. So, yep. Coming at us. It shouldn't be too super major, though. Now, we do have the coronal hole that's off to the side. That's also going to play an effect. So, it could actually be pushed off a little bit. Here, let me show you here on this one here. And bigger, and I'll actually just bring this up ahead for it. So we have this coronal hole, which is, now when coronal holes are blowing solar winds, they don't just come out in a straight line. They kind of, blow out in all directions. So if we watch this, we can kind of see how it actually affected it, and you can see how when it came off on the 304 in red, we've seen it whipping over here and over here. It's because, believe it or not, it's because of the coronal hole kind of pushing it off a little bit. So yes, it's coming our direction, but it's not going. I don't think we're going to get a full solid smack from it. It's probably going to be more like a little glancing blow. So we're still going to get some, but I don't think it's going to be the full force. For those of you who are new to this channel, welcome. For those of you who have been following my channels and watching some of my other episodes, you guys will recall I have actually shown you guys this little bugger before. This is one of the other reasons why we're not going to take a full hammered hit. If you notice here, we've got this. Some people say, oh, it looks like a shield, like a deflector shield, if you will. And then it kind of comes down to this point right here, to this guy. Okay, this right here being our artificial sun. This is the Earth, daytime side, nighttime side. This right here, this is Venus. This is the nighttime side of Venus, daytime side of Venus, and the sun is over here. So things that come over here, now this is our artificial sun. I've actually shown you this stuff from NASA. This is NASA patented. Okay, so as these things do come our direction, it will affect and kind of deflect some of these, this plasma that's coming at us. So granted, things are still going to be running down our geomagnetic line to the Earth, and it will come down and from the top, and it will come up from the bottom, but it's not going to be as hard of a blow. So let's do a quick little watch here of our little guy in action here. You can see the sun here, and you can see the rays and the plasma coming, and well, you can see it actually affected the satellite here. And it's kind of hard to see because of the interference, but it actually does kind of shield us just a little bit. It takes the major punch of it off, which is quite nice, in my opinion. And this is the same one, but it's been a little bit cleaned up for us, so we can actually see it a little bit better. And as things come around, it's going to naturally go around us a little bit more, and it's actually quite nice to see. Pretty cool, huh, folks? Now, we're going to jump over here to ISWA, and to touch on my previous video on, I'm not sure if it's the sun that's tilting or if it's the Earth that's tilting, which is why the sunspots are looking at an angle like this instead of like this, going horizontally, and they're kind of more to 45. Well, it's kind of hard to say. I mean, I have heard about a lot of the Eskimos have said that the stars have moved position and they're not able to hunt because that's all they use is the star positions. That's what they've been doing for generations. So the Earth probably has a wobble going on to it, and it's been tilting according to the Eskimos up there in Canada and Alaska area. Now, one of the other things that could cause our sun to tilt. Now, I want everybody to think about this. What are we looking at right here? Okay, what we're looking at stereo ahead. Corner graph 2, this is with the science data, and this is the running difference with the science data. You guys see a nice large round object right here? And here? And here? Especially right here in the middle. This would be Nemesis. Okay, this is our main star, and this is our second star. About the same size and density. Now what I'm going to bring it in just a little bit for you. And I'm going to hit the play on this. I'm actually going to just tap on it a little bit, and I'm going to show you. You can actually clearly see that it rotates. It has movement. It's not coming out of the sun. It's coming around from the back side. And our sun just gives a nice little pop because it's obviously pissed that it's there, and it pushes it off. Well, as our sun has a north and south pole of magnetic field, well, so does our second sun. So they dance. They do this little dance where they attract, and then they push away. They attract and they push away. It's this really funky little dance that they do. And you can see that it is rotating. You can see the plasma being pushed here, and it goes around our second sun, which is a red dwarf star. It's a failed star, or one that's like burnt out. So we can clearly see it being pushed off on this one, right there. And away she goes, and gets far enough away from the light so that we can't really see it. So when we come over here to this guy, And don't forget, we got our space station here on the back side of the sun. This actually stops here, so it doesn't go any further than that. But here, oh, hello friends. What are those? We know what those are, don't we, folks? So we can see our little friends, and it looks like a battle formation again. And we can see it coming off and spinning it. Almost like spinning it. It's almost looks like it's spinning backwards. Like, imagine a hand. Okay, with this here being the hand on the back of a basketball, and then kind of spinning, putting like a backspin on it, like a basketball shooting a hoop. Zoop, and then off it goes. And this one is the running difference. Hang on, let me get my finger on that one there. And you can kind of see the same thing. You can see the plasma, again, going around it. Imagine taking a hit of a cigarette or a vape pen and blowing at a ball. It's going to go around it. Okay? So just like that. And there she is. Now this one's definitely not as good as this one, but we get the idea. So with our sun doing this magnetic tug and pull, with our second sun, imagine this has a north and south pole, just like our sun has a north and south pole. And as the north and south start coming together, what's going to happen? Same thing if you took magnets and did the same thing. They're going to start going, and the south pole here is going to go, and they're going to start attracting to each other. Well, our sun has a cycle where it actually cancels itself. So the north, through magnetism, the north pole goes to the south to the equatorial plane, and the south pole travels north to the equatorial plane, and then they cancel each other out. And then the north pole actually has a south pole charge that goes down to the equatorial plane, and then the south pole has a north polarity charge that goes and meets there. So it goes red, blue, and then they cancel each other, then it goes blue, red, and then they cancel each other, and then back and forth. So as it comes closer and then it cancels again, it becomes a north and a south and a south, and then they retract, push each other off. That's how magnets work. You put two norths together, they're going to push away. Put a north and south together, clink, they're going to click together. So it's just one of those dances that happens. So if we think about it, that could be a good reason why it looks like, from the Bruce Sees All channel and from what I've been showing you, why that mothership is coming in and blocking the satellite, so that way the satellite can actually adjust itself at a 45-degree angle and see the sunspots at a 45-degree angle too, so that way it looks like we're seeing it nice and level and horizontal, like nothing has changed. Once again, to hide it from us. But good thing we have some people on Earth with good scopes and cameras that are taking videos of it and showing it to us. So it would also explain our poles moving. Our people are not aware that our north and south poles are moving, and that's something you can Google, current position of north and south pole, and you'll actually be able to see that the South Pole is no longer in Antarctica. It is in the middle. It is in the ocean, and this little bugger right here would be a real good reason why. So stay safe out there, folks. We're looking to be hitting about 5 to 6 days. So everybody stay safe out there, and remember that love is the only way forward. Eyes open, no fear.